Okay, I think we've got quite a few people on the call now. So as I said, I'm Simon Pearson. I lead the digital team within the Energy Systems Catapult, and I'd like to welcome you today to what is the fourth event this week in a series that we've been running all week. Each time we focused on opportunities and challenges associated with digitalisation of the energy system. We all know that digitalisation is critical to the transformation of our energy system if we stand any chance of hitting our 2050 decarbonisation targets, amongst other significant challenges. And each day this week, excuse me, we've been focusing on and exploring different aspects of digitalisation and the potential roles that each of those disciplines, if you like, can play in the transformation. Today's session considers the importance of interoperability across the energy system and the role that standards, including the recently published PAS 1878 and 1879, can play in this, which we feel is a really important area given the increasing complexity and distribution of the energy system, the change in behaviours that are coming in, the new platforms, smart systems, appliances, energy services that are coming along, and all of that, and how that interplays with consumers. So hopefully you will find the session today informative and enjoyable, and it'll also give some signposts to how you might get involved beyond today's session. Although it's a webinar today, it's really a way to stimulate further discussion and engagement. We're going to have a couple of presentations to start with, and then we'll have a panel event at the end. And we're joined today by Mark Berkeley from BP Lightsource, who's the Research and Innovation Director there, and Dr. Nina Klein from BEIS, who's been heavily involved, in fact, probably led the development of the 1878, 1879 standards. So they will participate in the panel later, and they'll introduce themselves more fully at that point. During the course of the event, if you want to raise any questions, please do so during the chat or in the chat, and we will respond to all questions beyond the webinar today. If there's time at the end of the session, we'll pick out some of the key questions and respond to those as well, but feel free to raise them. If we can answer them during the session, we will do so as well. So with that in mind, I will now hand over initially to Daniel Mee, who's going to lead us through the first part of the presentation, followed shortly after that by Rebecca Sweeney. So over to you, Dan.
Good morning, folks. Thanks for attending today, and for giving me the chance to talk to you. I work in our systems integration team as a senior manager for energy systems architecture, which broadly means the big picture structure of how things fit together. I was fortunate enough to work on the PAS standards with Nina, but most of my focus is on fitting interoperability standards around how things work, the commerciality, the policies and regulations that need to come together to make all of this hang together as well. So interoperability beyond technical compatibility. Let me just share my screen and I'll get into the slideshow. Right, I trust someone will shout up if that's not sharing okay, but I presume it is. So why do we need interoperability? I've put this little chart up. The data's from some of the established from Gartner and their work on looking at innovation and the path of innovation. So what this shows is the rise of market share of different mobile phone handsets, and I've superimposed the dates when standards were published and when adoption was taken on, and so you know, one of our big shouts is that interoperability is absolutely critical to building a big market. And I think sometimes there's a conflict between having proprietary standards to keep everything sort of protected and protect ecosystems. But what we've seen across industries, mobile digital telephony is one example, is that you can have a smaller market share of a much bigger market with interoperability. It's absolutely a given. As I said, part of my focus is to think about interoperability beyond the traditional sort of device and technology interoperability. And so some of the things we talk about are consumer interoperabilities and making sure that products and services are geared for consumers changing their mind and switching choices, moving between suppliers and offerings. That businesses are commercially interoperable in that they can share information, that they can transact the things that are important to different businesses, so we can get proper flows of liquid markets. That data is interoperable, obviously critical here, but sharing the portability and sharing of data, a lot of this comes down to then the ownership of data, who really owns that data, who's responsible for it. Then device interoperability, which is probably the one we most naturally think of, which is can device A talk to widget B? Can we share information across? Can they interact with one another? Physical interoperability, then meaning that can some devices fit and interact with the network? So, you know, are the voltages and the physical aspects, are they aligned to one another? Can you actually work? There's a lot of work going on at the moment on hydrogen, for example, and hydrogen interoperability around purity. You know, what purity of hydrogen is flowing through the pipe, and what does that mean for end devices, and can they use that? Are those systems interoperable? And so, first hint there that this goes far beyond electricity. And then finally, vector interoperability. And this one's a bit more of an esoteric one, but looking to see that decisions made in one space are supportive of another. Where this matters for the consumer end of things is things like hybrid heating systems is a good example. If you're going to switch between, say, gas for heating or a gas for heating and electricity, are they aligned such that the planning for sufficient resources can be met by the different suppliers, retailers, network operators throughout the system? And you know, like I say, the data is moving across to make informed choices there. So I use this as an example of the different types. So consider a smart device like a hybrid heat pump connected to a smart home hub. So that's the device interoperability, that they are connected together, which can respond to data because the data is formatted in a certain way that means they understand one another, which provides guarantees of behavior at a given price. So this is that things are commercially interoperable. I suppose what I'm trying to get at here is the devices themselves can be technically interoperable, but if businesses can't make money and get access to the sorts of flexibility they want at certain prices, then we're not solving the full problem. I mentioned the point about vectors, being able to switch between vectors where that's appropriate, and then that it can alter the properties that it needs to. This one is a particular favorite of mine because I say that kilowatt hours weren't created equal, and so being able to give a kilowatt of flexibility on a hybrid heat pump, on an electric heat pump, versus a EV charger are actually different. They have different electrical properties, and a DNO requesting flexibility might want something very specific. So we might have to trade more information than just how much energy I can give up. And then finally, the consumer interoperability, that they're able to move with their products and services, with their data, to another supplier if they're unhappy or if they can find a better deal elsewhere. So why else do we need interoperability? This chart, I'm not going to go through it in detail. It's in one of the reports on the Catapult website around interoperability, but I'm just trying to illustrate that there are many motivations for flexibility. This top row sort of indicates the sorts of organizations that might want to procure flexibility. The bottom row are the sorts of users who can offer up flexibility, and the middle row is our businesses, our technologies which can enable flexibility. And you'll notice straight away some people appear in multiple rows, and there should be many more lines between them. There's almost lines between every box, but I've removed a lot of them for clarity. The point here is that why an ESO wants flexibility for, say, managing frequency services is very different in what they're looking for to why a DSO of the future might want flexibility, which is to manage thermal constraints in a very specific local area. The sorts of data that an ESO would want to see to enable flexibility is very different to the sorts of data a DSO would want to see. And so when I talk about interoperability for commercial reasons, it's absolutely trying to understand who wants to see what, so that we are building products and setting standards which allow trading with multiple organizations for many different reasons, trying to keep it as open as possible. Next, there's the one on the right isn't blurry, by the way. It's two maps poorly overlaid over one another. I'll get to that in a second. But geography matters for interoperability. The diagram on the left here are the county boundaries within the UK, and the section at the top of Wales with a blue outline is the SPEN area of DNO. The distribution network operator, they own that. Everything south of the green line until you get to Bristol is why is that name dropped out of my head? Excuse me. That's the Midlands electricity, and in the red area, the red boundary, that's Electricity Northwest. Now, the area I've circled in black is actually Knutsford, just south of Manchester Airport, and there is a street where you can see the three areas come together in terms of ownership. Now, it's entirely possible that somebody lives in one of those areas, works in another, and has family across the border in another. And traditionally, we've had less of a problem with geography because everything's been nailed down. But as we now move into EVs and EV charging, our energy resources are going to move around. And the idea that we'll have some regions operating one way or some towns operating another just seems like it's untenable in the long term. So we want interoperability to make geography work. On the right-hand side, what I've tried to illustrate is that the DNO maps and the GDNO, so this is the gas distribution and the electricity distribution owners, they also don't line up. And so when we start talking about things like multi-vector control and hybrid heating technologies, the coordination between businesses won't even be with another business in the same area. The sites overlap. If we then were to get political boundaries, they also don't overlap naturally with any of them. So it's all of a bit of a mess. And as we now proceed with talking about local energy systems and local authorities being responsible for net zero, these are just some of the considerations of why we would want interoperability across boundaries there to make sure we can work in the greatest number of places. So in terms of devices, I think we know there are hundreds of controllers on the left-hand side, and these are pretty narrow. These slides are a bit old now, so we know there's more. There are thousands of appliances, millions of homeowners, and again, at least tens, if not hundreds, of service providers and retailers. And so there's a danger of having specific point-to-point interfaces between those parties, when realistically you want to be able to move between different suppliers and different products and integrate within homes. So rather than have lots of links, lots of proprietary standards, something we think is a better way to go is to have this interoperable market where you can move between the component pieces. So a bit of a technical slide now, taken straight out of the PAS. The PAS provides an introduction and a set of standards for how to build energy smart appliance technology, how to get them to interact. I should say there's PAS 1878, for those of you not familiar, which talks about the technical interoperability and the standards for devices to communicate with one another. And there is PAS 1879, which is a code of practice to help innovators develop demand-side response services. Both of those PASs are compatible with the smart metering system, although are not dependent on it to operate. And they basically talk about the devices in and around homes. They are geared towards domestic customers. They talk about the customer energy manager, which is an interface then to bring the data together from those smart appliances, and that interface off to what's been termed a demand-side response service provider, somebody who is asking for flexibility. Some of the core component parts or the core features of the PASs, I'll go through these now, so for PAS 1878, like I say, this is for the smart appliances. It is a standard, but it's a PAS, which means it's been a group of specialists convened to rapidly produce a standard, as opposed to a full British standard, which generally takes longer to put together. They cover routine commands, which is effectively time of use and what I'd term indirect requests for flexibility. So sending homes price signals, for example, and asking for a response. And they also cover responsive or direct command control lines, which is a request. It's still a request rather than a directive, but it's a request for direct action. So turn up, turn down, turn off, turn on, that kind of thing. So it covers both of those pieces. Very critically, though, it puts the final say with the consumer. They are requests rather than firm demands. It's predicated on each device offering its own flexibility via the SEM to the service provider. In other words, the end device knows what it can offer up and still meet customer requirements. So it won't offer up flexibility if it means the customer will be too cold or their EV won't be charged in the morning, and communicates that out. On that previous diagram, you'll see that it shows interface A and B between the DSRSP and the SEM, and the SEM and the smart appliance. So it defines those two interfaces. It doesn't mandate a box in the home. It's a cloud or home presence for the SEM. And as I mentioned before, it's compatible with smart meters. A lot of this work's been based on the Senelec work that's been going on in Europe. And so it's compatible with that thinking, although we're still waiting for a lot of publication from some of those standards. There's a plan to review these at a frequency of less than every 2 years, and there's already thinking about what will go into future revisions. On 1879, the core features are, this is a code of practice, so it's not a standard, it is a set of recommendations and advice, and is intended to stay that way. It provides a common definition for services around these four principles that are listed there. So first of all, the interoperability of the services. There's a lot of information on the requirements for data privacy and its impacts on security. There's work there on how to ensure some grid stability, and obviously the cybersecurity aspect. Again, this standard is compatible with the approach for smart meters, but not reliant on there. I've mentioned the excuse me, I mentioned the compatibility with the Senelec standards. So that's it from me. If there are any questions on any of this, please put them in the chat box, and we'll be happy to pick them up as we go through. And I shall hand over to Becky.
Thanks, Dan. Becky Sweeney here. I'm the business lead for Living Lab here at the Energy Systems Catapult. And the Living Lab is a national trial and demo facility. We've got homes across the UK who have signed up to help us test out new products, new services that innovators are creating to support the transition to net zero. And here at the Catapult, we have been exploring consumer needs and behaviours when they're using energy in their homes since 2012. And in order to provide a safe environment to engage with consumers, to understand what they want from energy products and services, we created our Living Lab. And we found that having a facility that's ready to go, ready to use, we're able to get really rapid feedback for innovators to allow them to refine their offer and get to market really quickly. So if I go into the first slide, Dan, I'm going to start by just briefly discussing the need for consumer-focused innovation and the need for interoperability. So as Simon said, as we're accelerating towards a net zero future, there's going to be a shift wholesale around the way we use energy to heat our homes, and also for transport within those to and from those homes. We've already done a lot to decarbonise the grid, but the next wave of change is going to be right at the heart of people's homes. It puts consumers in the centre of that transition, and we really need to work with consumers so they want to embrace that change. And a really good way of doing that is to provide them with services that wrap the things they want, comfortable warm home, easy mobility, into a new service proposition they'd be happy to buy. And importantly, one that they can afford. So managing the delivery complexities for these new services needs to be done seamlessly. And importantly, this is going to be underpinned by connectivity of digital tech to create that service for the consumers. So that's why we think interoperability is so important. We'll go to the next slide, Dan. Thank you. So over the years of operation of the Living Lab, in response to this need, we've developed it to create something we think is pretty unique. So it provides, as I say, quick and cheap access for SMEs with this ready-to-go facility. And it provides the facilities needed to test out novel market designs, novel pricing arrangements that might be needed in the future. It allows the innovators to test their ideas, to de-risk them, refine them, find partners, and then get evidence to justify further rollout and investment. And with the digital platform, which is a core thing we've developed as part of the Living Lab, we can link commercial off-the-shelf technology to support interoperability and provide an ideal place to test out and potentially design emerging standards in this area. So we're really excited to see how we might test these new price standards. So we think the lab's a key enabler for this digital transition in energy. And of course, on top of all that, it helps the Catapult achieve its objectives, which is to grow the UK energy economy, but also inform government and regulators on potential future policies. And the next slide gives a really simplified sketch of how the lab works. So at the core of the lab, we've got people. So we've got now 260 homes scattered through England, Scotland and Wales who have signed up to help us test out tech and services. And we're expanding this lab quickly to meet emerging market need. We can run multiple trials at the same time, with small groups of these homes signing up to take part in a trial based on offers they see. And where we need specific homes or people or technologies or combination of them, we'll recruit additional homes or install equipment and monitoring to suit the trial. And central to that, connecting all this tech and the data going to and from the homes is managed through the digital integration platform, which was built by Simon's team working with an SME called Sysmic. So Sysmic have got a lot of experience managing data for mobile phone companies, and we worked with them to deliver a platform to integrate smart energy tech. And that allows us, as I say, to connect this commercial off-the-shelf tech through API adapters. On the next slide, I'll just give you a flavour of the sorts of trials we've been running. You can move it forward one, Dan. Thank you. So the sorts of trials we've been running to explore consumers' attitudes towards energy services and what they need from them. So we've tested a range of energy services. We've explored their preferences around concepts such as heat as a service, where we deliver that through consumers selecting warm hours for rooms within their home. And we've worked with Baxi and Bristol Energy on that. We've also explored how mass market consumers, when given an electric vehicle, respond to managed charging. So would they potentially allow their EV to be charged in the middle of the night when demand's much lower, rather than charging it when perhaps come home from work, the height of the evening peak? And we're working with Ampex right now. They've got a digital energy assistant that we are rolling out into a number of homes within the lab to explore flexible use of energy in the home and help them refine their offer. So across the various services we've tested, and these are just a flavour of them, generally consumer feedback is really positive. They really value the outcomes they get. And whilst you do have certain early adopters, probably lots of you in the audience have got an interest in kind of stitching together tech, making it talk to each other. Consumers generally aren't that excited by doing that. We've found from our research that consumers often aren't getting the outcomes they want right now from heating, for example, within their home, having to create workarounds, perhaps blocking up air vents, which reduces the air quality, potentially growing mold within their homes. So they're not always getting the outcomes they want, and they're spending time and effort trying to get them. Whereas if we've found when we've offered them a well-designed energy service with tech that just seamlessly integrates, is interoperable, and connects with kind of other tech within their home to give them what they need, they generally are quite accepting of that and really value it. So on the next slide gives a flavour of the sorts of trials we have run across the Catapult, whether that's kind of testing product performance and consumer experience, looking at various as a service offerings, testing out business models and exploring energy flexibility. But the thing that underpins all of that is interoperability. And the next few slides, I'll describe the approach we've used, which is, as I say, really centered on this digital integration platform. So the next slide has a drawing of the various technologies we've integrated with in our kind of first version of this digital platform. So we've signed up a number of technology partners to integrate this core of technologies to support us delivering trials. So we've got smart meter integration. We can connect in various sensors via Samsung SmartThings. We've initially connected with Tado to provide that zonal room heating control, EV Energy to provide managed charging. And it's great to have Lightsource BP with us today, as we are now starting the integration of their smart home energy management technology, which they call Tribe, which will allow monitoring, control and optimization of electricity from generation within the home, from solar panels perhaps, storage, and also other consumption devices across the home. So it's really exciting to have them forming part of that core group of technologies in the lab. We are looking at clustering, or we're actually actively starting that now, clustering energy usage from the home so we can explore network impact. We'll shortly be announcing a competition to find a heat and or battery storage partner and bringing in vehicle telematics so we can understand what's happening with energy usage in the cars as they're away from home as well. But we are always seeking additional partners to work with us. So this next slide shows how we use that digital platform to support interoperability of tech during the trials we run. So on the left-hand side, if you're an innovator who's got a new exciting energy service you want to test, you want to bring it into the lab to test the appeal, perhaps unpick a little bit more about the business model, willingness to pay, pricing of it, and working with consumers. You can do that by using the integrations we've got in place. So we can use our existing integrations with perhaps perhaps usual integrations with EV Energy, the heating and hot water integrations we have, and test out how that service lands. If you're an innovator, perhaps with a new product, you might have a consumer offering which would need integration with other techs. Maybe you need to integrate that with EV charging or battery storage tech. You could come and test that in the lab. And how we'd do that is we'd work with you to create an adapter. And this would allow your tech to then work with the other tech we've already got integrated through that digital platform. So by this, we remove the need for lots of point-to-point integrations. So it reduces the cost to trial these ideas, which is great to have in a short-term trial, but then of course we need to take that to market. So on the next slide, we cover that. So in order to launch in the market, an integration layer between the tech is then needed, which is shown on the left-hand side. And that's because right now we don't have a set of interoperability standards that have been fully implemented. It's great to see these PAS standards coming out. The learnings from the trial could be used to support the development of that integration layer. But I think one of the important things is you're only kind of putting the effort in of creating that once the innovators got confidence from the earlier testing that the product or service has appeal. And perhaps from working with the tech partners in the lab, they'll identify ones they want to take this service to market with. Oh, sorry if I go back on, Dan, sorry. Yeah, ideally, of course, as I say, there'll be integration standards implemented. And on the right-hand side, we're kind of showing how that implementation of standards allows the removal of that integration layer. And we're really keen to work with innovators to explore how these new PAS standards could practically be implemented. Next slide, which is Dan's fab 6 types of interoperability. We can see how the Living Lab supports the first 4. So we can use the lab to explore consumer protections, explore market design, the data, the devices, connectivity. But on its own, the Living Lab doesn't cover the end-to-end from consumers right the way through the electricity or other systems to supply. It doesn't explore cross-vector interoperability. There's a limited amount of cross-vector within the lab, but it doesn't support exploration of the kind of full cross-vector interoperability. And in order to address that, if we come to my last slide, We've been working really closely, Dan and I, with the Power Networks Demo Centre up at the University of Strathclyde to create a whole energy systems accelerator. So this will enable consumer energy demands from homes within the lab and their network impact to be explored real time in a facility which connects those living lab homes digitally with the test networks they have installed up at the Power Networks Demonstration Centre, with that full feedback loop back to the homes via a market emulator. So you can test out different pricing signals, different market arrangements, different scenarios live in a protected environment. So this will allow us to support those kind of final two aspects of interoperability, the end-to-end system, and also the cross-vector interoperability. So that's my slides. If I now hand over to, I think it's back to Simon at this point.
Thanks, Becky, and thanks, Daniel. So yeah, I think you can see from the material presented and the enthusiasm from Becky and Daniel there, we're really supportive, and we think the whole interoperability and the emergence of these standards is going to play a huge part in moving things forward, both for the transition, for the energy sector, if you like, the network operators and the various actors and players in there, for commercial entities who want to develop services and sell products in that space, and ultimately for the end consumers, because they have to be brought along with the journey. So the next bit really is a short panel discussion where we'll pose a few questions to the panelists, just to explore some of the practicalities of that. We're lucky enough, as I said earlier, to have Dr. Nina Klein and Mark Berkeley to support us on the panel today. Nina, could I ask you to just introduce yourself briefly, please?
Yeah, good morning, everyone, and thanks so much for the presentation. It's really interesting to see what the Catapult is up to and is doing. So good morning, everyone. I'm Nina. I work as an energy engineer at BEIS. So my role is to give technical advice to ministers and policymakers. I've been working particularly with the team who are developing and will be shortly releasing a new version of the Smart Systems and Flexibility Plan. And I also work with colleagues in OZEV on smart charging policy, and interoperability is a key principle across those policy teams. And as Dan mentioned, BEIS funded the British Standards Institution to develop those two PASs, PAS 1878 and PAS 1879, and I was coordinating that from the BEIS side of things and was quite deeply involved in the technical drafting, so I'm happy to discuss any of those gory details. And I should say as well, those PAS standards are freely available online, so I'll put a link in the chat for anyone who'd like to download them. Thanks.
Thanks, Nina. And Mark, if I could ask you to similarly introduce yourself, please.
Good morning, everyone. Thanks for the presentations. Yes, they're very interesting. Lots to learn there. I'm Mark Berkeley. I lead the embedded systems development of the Tribe Hub in the labs division of Lightsource BP. So we're building a home energy management system to maximize self-consumption of solar energy and minimize the cost of imported energy through scheduling and availing of time of use tariffs and so on. My particular focus is on edge devices and IoT technology, which underpins energy management in the home. And the view here is to enable intelligence and autonomy at the edge. So not everything has to go through the cloud. The edge is autonomous on its own. Standardization is particularly interesting to me and my team because we're coordinating many smart appliances and discretionary loads, such as EV charge points. And to maximize self-consumption, we need to coordinate these and in a controlled way, and also be able to participate in demand response and flexibility networks.
Thanks, Mark. That's great. I think Becky and Daniel, you've already introduced yourselves as we've gone through. So I think we'll move on to the next slide, please. Okay, so I've got 3 starter for 10 questions today, which hopefully will generate some interesting discussion. I think Nina, if I could aim the first question at you initially in terms of, we've covered it a little bit, but why, from your perspective, the key part of this panel discussion is really I'm looking for perspectives on why these are important rather than generic. So from a BEIS and policy point of view, why it's important, and when Mark comments on it, I'd like to see it from an industry player in the sense of somebody providing products in that space. So So from your point of view, Nina, why is interoperability important in that transition, and how do you feel the standards really support that?
Yeah, I think one of the kind of viewpoints government can often take is that I guess we can kind of sit in the middle and see a lot of viewpoints across the whole system. So hopefully I'll say lots of good whole systems things, which I know Energy Systems Catapult is very hot on. And I guess, and also of course, the other kind of key thing from consumers is public protection and consumer protection. And so I think from that first kind of system level point of view, as we're moving to net zero, we're going to have so many kind of variable renewable energy sources on the system that we're going to need to transition to a point where demand is matching that variable supply, rather than where we are today, where variable supply matches demand. And so because you're going to have demand matching supply, we need these smart appliances and this smart demand on the demand end. But the key thing is that interoperability of those smart appliances will mean that we can get enough of them to use them together in aggregate. And the reason why that's important is because if we're trying to match supply, we need really, really large numbers of megawatts. And if we're trying to provide grid services, we need large numbers of megawatts to provide those services. And so by having devices that are interoperable, an aggregator can access many of them, onboard them onto their platform and use them. Whereas if it's kind of siloed by manufacturers and it's only their individual market shares, I don't know if we're going to get that kind of critical mass to be able to have these business models to provide these services that are large enough in scale to support the energy system and make a meaningful difference to balances on the grid. So I think from a system point of view, interoperability gives you critical mass in a really important way. And then from the consumer point of view, I think the point's been made really nicely by Dan's slides, but interoperability gives consumers more appealing products because they're more compatible. As Becky's kind of been pointing out, consumers want ease of use, seamless integration. So I think from a consumer point of view, products are more appealing, which I think businesses can think about when they're building their products. But also, really importantly, that lock-in point, we don't want consumers to be locked in to single providers. They need to be able to shop around, because also that enables more competitive markets. Consumers can get the best deal, which should lower prices, which then kind of in turn should mean lower prices for the electricity system as a whole, and everyone benefits, not just the person who buys the appliance. So yeah, I think a lot to be gained from interoperability.
Okay, thank you. Great answer. Mark, maybe I could ask you to comment on that, because it's always an interesting point. Dan and Nina have both touched on it in terms of, you know, the pluses and minuses of standards in the terms of everybody doing it in the same way, but you know, maybe does that constrain innovation, if you know, or how you gain market share, for example. So what's your perspective on the life of standards from delivering products in the space?
I fully agree with Nina. I mean, interoperability, standardization aids ease of use and seamless integration. And these are both key barriers to consumers adopting smart management systems for the home. I don't think it curtails innovation in any way. I think it enables it, because, you know, rather than having a plethora of interconnected proprietary protocols, appliance builders and you know, manufacturers of inverters and batteries and EV chargers have a, you know, ideally one standard to deliver to, and then that opens up an entire market to them, rather than having to build the entire vertical stack themselves.
Okay, sounds good. And Becky, would you like to comment on that question?
I don't think I've got anything to add from what Nina and Mark have said, really. I think, as you know, interoperability is core to giving consumers what they need. It's core to giving them a full range of services that can draw on a number of different techs to support the outcomes they want. And standards help people have a common language to have those data flows going backwards and forwards from each other too. So yeah, I should be with everybody else. Okay,
thanks. And I'll ask the same question, but maybe with a slight a twist for Dan then, I guess, is one of the challenges that always comes up with these interoperability standards, I'm from a different background outside of energy as well, is the challenge of fine-grained definitions of them that have a high degree of detail to make it very interoperable, but therefore sometimes limiting what you can and can't do without going outside of those boundaries, or coarse-grained, which gives you much more flexibility, but maybe less interoperability. Do you have a perspective on that?
I think some of that is reflected by the fact that PAS 1878 is a standard and does say, for interface A, here's what you send backwards and forwards, and PAS 1879 for the demand side response services being a code of practice and a set of guidance and principles that need to be adhered to. I think there are some things which absolutely should be specified. So, this is the data standard between the two things. It's no good if you're not talking a different language, and maybe even physical connectors. I don't think any one of us decries the USB standard. It's fantastic. It's helped us do lots of things with consumer gadgets. But on the security side of things, for moving data backwards and forwards, that's such a fast changing field that fine-grained specification of that would probably be a barrier to keeping up with the threat. So setting performance standards of it must be secure against these sorts of threats, which you can then implement different methods and verify that you've achieved them through different means is absolutely key. So yeah, horses for courses, I think.
Good answer, thank you. Okay, moving on to the second question, and it was touched on earlier, I guess, but a lot of the time when we're looking at standards, inevitably it looks like a technical thing, and I think there's a lot more thought to be done in terms of how these things can really support the outcomes and the services that we want. So if I could target the question initially at Becky, you touched a little bit on your presentation, but how do these develop the emerging new services as opposed to the technical integration of widget to widget?
So I think I always go back to Dan's 6 types of interoperability. And I think all of those features are really important when you're developing an energy service for a consumer. So the first one around enabling them to switch providers. So just be able to switch providers with the tech they've got in their homes for actually delivering those outcomes. So making sure we've got the right protections in place to enable that is core. It's really important. What you don't want to be stuck with is a piece of tech that doesn't then work with the next energy service provider you go to, the next energy company who's supplying your electricity, who's providing that outcome to you. So enabling that interoperability is so important. If we think about cross-vector interoperability, again, that's really important for a consumer who wants their home to be warm to a particular temperature for particular periods of the day. They're pretty agnostic as to what that energy vector is, supplying that heat to them, as long as it's provided consistently and it's provided at a good price. Being able to have interoperabilities between the energy vectors which are supplying that heat to their homes, perhaps with a hybrid heat pump in the interim, provides options in terms of the network, the grid flexibility that Nina alluded to. So again, interoperability between network vectors is so important too. So I think without interoperability, we're unlikely to get the level of services that will attract consumers to adopt some of these low carbon technologies. So it really underpins it for me.
Okay, thank you. And maybe I could come to Nina next from a policy point of view. There's a couple of questions in the chat around this, and again, policies and services kind of closely related sometimes in the sense of one driving the other. So what's your perspective on how it supports the service implementations through standards?
Yeah, I think the policy here is it's a tricky space, right? Because I think the way policy is approaching this is by setting out some quite key policy objectives in terms of outcomes. So interoperability being important, consumer data privacy being an important policy principle, cybersecurity being an important policy principle, and grid stability being an important policy principle. And so setting those principles and saying they must be achieved while leaving space for innovation, because it is such a nascent and growing sector, is kind of it's a difficult balance to strike, making sure you achieve those principles while still leaving space for innovation for these new products which consumers like and want to buy can be developed. And so I think that's where kind of the approach to PAS 1878 is quite helpful. PAS 1878 and 79 is quite helpful, because it kind of set a minimum common core functionalities in terms of a minimum standard that allowed those 4 principles to be developed, but didn't necessarily go further than that minimum core, because then you can leave that space for people to innovate on top of a common baseline, which I think kind of comes to a point where we kind of left off with the last question. I'm going to do a terrible analogy here, so apologies in advance, but the Euros are happening at the moment, right? And it's almost like at the moment, if you were to put a football pitch out there, some innovators would come on and play football, some people would come on and play basketball, there'd be some people playing netball, someone would be throwing around a frisbee, like everyone's doing it in their own different ways. And so if you wanted to come along and watch a football game, it probably wouldn't be a great consumer experience. But if we can say, hey, everyone, this is the rule for playing a game of football, then everyone would at least be playing the same game. But then equally, I think you even need another level of kind of coordination in terms of, okay, we're all playing by the same rules, but equally, how do we make sure that there's the right, like only 2 teams on the pitch at the same time? Like if everyone was playing football, but all together, it would still be bad. So you need to organize your knockout stages and and so you kind of need a framework for how we're all going to operate together, as well as having the same rules, but still people can do fancy kicks and decide how they set out their team and so on. And so it's like you need this kind of common view to then work together and do the exciting stuff on top, I would say.
Okay, good answer. I like the analogy. In fact, it actually leads on to the question that I sort of spin on the question I was going to ask of Mark, actually, which is one of the diagrams that Dan put up showed the sort of the different different layers, if you like, providers of flexibility, the facilitators in the middle, and then the beneficiaries, the people who need the flexibility at the top. And of course, one of the challenges is each of those has their own motivation for why they might or might not either want to provide or access flexibility at a given time. But then each of the entities in there, particularly the technology providers such as yourself, are in usually one of those layers, and so have very specific motivations of your own for your technology. So how does this interoperability and the standards help bridge that gap between those layers and the individual motivations of the entities?
Good question. Yeah, the motivations, I mean, in the energy providers, the demand response service operators, the motivation is a standard way of communicating with distributed energy resources through the CEM. For companies like ourselves producing the HEMS, our motivation is that we can talk to different operators, different providers, talk to different appliances in the home, and expand the list of certified appliances that we can operate with. The consumer benefits, just to build on Becky's point, by having more choice. They can choose appliances, and they know it's not just a question about switching providers. You can also switch your appliances as well, with confidence that whatever appliance you choose is going to be compatible with the current demand response plan you have. So I'd see those as benefits.
Okay, and Daniel, anything you want to add to this one?
Yeah, briefly, I think it's clear that we should let innovators drive innovations. That's the way to keep it moving at pace. I think the device standards, what they intend to do is provide a stable palette of data and actions that you can choose from in order to access to drive behavior. What I'd love to see from policy is actually nothing to do with the standards, but a clear indication of what is valuable and by how much is it valued, which parameters, and that I think comes down to who's responsible for what. So, for example, the DSO conversation rolls on. Hopefully we'll get an answer as to what a DSO is responsible for soon, but we don't know, and we don't know what the split is between an ESO and a DSO, and we don't know what the future of the retailer hub model is, and we don't know where aggregators fit in really. And even when somebody suggests, oh well, DSO is responsible for that, sometimes I think there are conflicts that haven't been thought through yet from the whole system perspective. So, if a DSO is being a neutral market facilitator of buying flexibility to ensure the networks are well protected from overstress, what about the fact that there are retailers who are setting time of use tariffs which are dependent on how windy it is at the moment? If it's very windy, energy is cheap, use it, which will presumably cause networks huge amounts of stress as more people use it. So there are conflicts in the motivations, and I think some policy that says, these participants are responsible for these things, and this is how they're going to do it, will allow innovators to deploy the standards to be able to access the value that's created from that.
Okay, great. Yeah, it makes a lot of sense. Some really good points there. I think that that overarching thing, which I think is something Nina played to as well, but it is, as you say, it's an incredibly complex system of moving parts and getting more complex by the day and the month. And so the ability to somehow figure out how it works without creating as many problems through the conflict as you get through the services that you can get is going to be key. which might play in probably to the third question a little bit. I think from the presentations and the first two questions, clearly lots of support for all of this, and generally it feels like everybody thinks this is the right idea and the right approach to move things forward. But inevitably, it's not going to be that straightforward. So I guess if I pitch it at Mark in the first instance, what from your perspective might be some of the barriers and challenges to getting this widely adopted? And I mean widely adopted because standards are great, but only if there's sufficient, wide adoption behind that to make it really work. So how do you see that?
I think a key aspect of that is to try and get the manufacturers of smart appliances and smart chargers and inverters to buy into this philosophy. IoT, which I said underpins the energy tech, has traditionally produced fully vertically integrated solutions. So you end up with a device in your home, a proprietary hub in your home, a proprietary protocol to a cloud, and a proprietary app on your phone. So you end up with 15 different apps on your phone to control all the different aspects of your house, and none of them talk to each other. So, I think some of that comes from the manufacturers. They're resistant to provide standardized interfaces. Maybe they're afraid of being commoditized. Maybe they're afraid of losing revenue streams from multi-subscriptions or so on. But to get them to buy into the benefits of standardization and to get them to avoid the huge mess of interconnected proprietary protocols, that it's a benefit to them. It opens up a wider market to them, and it allows them to innovate features in their product and not get distracted by developing proprietary cloud protocols and so on. And then if they feed into a standardized CEM EMS, then that enables the service providers to be able to provide advanced services more easily as well, without having to build everything from scratch themselves.
Okay, cool, good, thank you. If I could pitch that maybe back to Nina now, and with a slightly different aspect to that, I guess, which is standards really work well from our point of view. You get easy adoption if there are two cases really. One is they're such a good idea and they're so compelling that it's just inescapably true that people want to do it, or they become mandatory and there isn't a choice. All right, and both of those get you wide adoption very quickly, one more popular than the other usually. What's your perspective on that? Because obviously at the moment, neither of the standards are mandatory, and they're obviously fairly early days. So what's your view on sort of carrot and stick type models or other ways to get adoption?
Yeah, and I think I've heard this from a few corners, and yeah, I think government is quite conscious here that I think there's a few. I think it's definitely a case of realizing that this is an early and nascent sector, and so people are still moving and changing and figuring out what products and services work for consumers, and so going too early could kind of stifle innovation. But equally, I think government's been quite clear about the need to protect consumers with interoperability as a key principle, and also the need to protect the energy system with cybersecurity as a key principle. And so I think sometimes there can be arguments that ask people to start doing things a little bit differently. But I think in terms of kind of encouraging uptake, it's nice if people see the benefits for themselves and want to do it because they realize it gives them market advantage and consumers are going to want to buy these products more. And I think that's hopefully kind of where industry will be going. And I think we can appreciate that, as kind of Mark was saying, some people in industry have done a lot of heavy lifting already and done a lot of point-to-point connections, and you can see why they might want to be able to kind of keep the market advantage that they've got from that. But there's kind of a phrase that, or a saying that I come back to, which is, if you want to go fast, go alone, but if you want to go far, go together. And I think people have gone quite fast, and there are some really cool products out there, but I'm not sure if the level of integration is enough to take us far enough to get to net zero. And I think that's probably kind of the message to say, which is basically Dan's first slide. It's a bigger market when it's interoperable. You might have a smaller share of it, but overall you're going to go further, and we're all going to go further together. So I think that's kind of the selling point to industry, that I hope that message can be communicated. And yeah, government is continuing to kind of think and consult as to where standards can be helpful and can help advance, and where there's industry appetite to pick them up, or where there's kind of really clear causes for intervention because the risks to the public could be problematic.
Okay, great. Maybe Dan, I could ask you to comment on this. Actually, I'm probably on the second half of the question, which sort of stems a little bit from that, recognising that it is a nascent and developing market, and some players are further ahead than others, and maybe resistant to change. Not they don't want to do it; they've already invested in what they've done to date, so it will take them some time to revector. How might you see these standards evolving in a way that can best address the needs of the people who need to implement them, the consumers who benefit from them, and and the sector as a whole on its drive towards net zero supportable interoperability? So what's the approach for that, for evolving them?
But I think in this sector that it's so spread out. There's so many participants, and often change needs to come all at once from multiple participants. So if we take the example of selling heat pumps, for example, there's a lot of drive that says the total cost of ownership is lower. So why not spend the £6,000 to £14,000? I'll leave the boundary nice and wide, because then hopefully I don't upset anybody with my price estimate. But I'll spend that up front because my cost of energy is going to be lower, and the world will be great. But that only makes sense if you can access flexibility services, which are few and far between at the moment and aren't really that valuable. They don't get you back £6,000 to £10,000 over 10 years' time. Notwithstanding the fact that most consumers don't think like that anyway. They're not thinking total cost of ownership. It's about, can I afford it today? And all the regular things we always say, when you're replacing a boiler because it's fallen over, you want a solution tomorrow, not, I'll think it through. But I think it's that, how does it result? How do we evolve them and maximize the benefits? I think, without being a sales pitch, I think things like the Living Lab that allow multiple innovators to come together, resolve the different component parts that need to change with standard interfaces, so that we can then see what the benefit is of 4 or 5 components playing together. Because it's great having a HEM system, but you need a flexible heat pump, and it's great having an EV, but you want to be able to do flexible smart charging and probably balancing across your house. So how will these things start to play together? And I think the standards as they are, as Nina said, it's an early standard, should be a starting point for us to go in, find out where they work really well, find out what needs improving, and then correct from there.
Brilliant, thank you. And in fact, a really nice segue, because one of the reasons I left Becky towards the end there really was, I have a view about the Living Lab in the context of evolution of these standards, because from heritage and other spaces, I see, standards by delivery and test is much more effective than just paper-based stuff. So Becky, would you comment on that?
Yeah, I totally agree. I think what we've done, so working with your team, Simon, in creating this environment where you can come out and test that kind of interoperability, work out what is valuable to consumers, what's valuable to a business to accelerate to launch is really important. And it's also providing us an environment where we can test out early versions of implementation of these past standards. As with anything that's new, they're not going to be perfect, they're not going to be right first time. There's going to have to be tweaks around the edges, and we'd like to help innovators work out what those tweaks need to be.
Fantastic. I'm conscious of time. I think we're pretty much at the end of the allotted time. So I'd like to thank everybody who's dialed in and participated and listened today. Hopefully you found it interesting and useful. Particularly like to thank Nina and Mark for your contributions. Really good to hear the insights from a policy point of view and from somebody at the sharp edge of delivering products in this space. Yeah, thanks very much. There'll be more information. We'll publish the slides and various other bits and pieces. Conscious of the fact that we didn't have a chance to get to all of the questions in the chat, but we will pick those up and respond after the event. So at that point, I think we'll close it here. And again, thanks to everybody for both participating and attending. Thank you.
Thank you.